right? Nice. The videos will be coming out soon. For those of you who attended, you get to relive your best moments. For those of you who didn't attend, you get to relive their best moments. And the photography will put a bunch of photos taken by our speaker today. He took photos for the conference. He has a fancy new camera he likes to use. So speaking of the pizza, everyone should go to bit.ly/pizza poll and rank the pizza from excellent to good, average, poor, never again. Go on there, rank the pizza. Today it comes from Highline Pizza up on 28th Street. I've actually never even eaten there before today, so this is completely untested. So please make sure you go to bit.ly/pizza poll. It's very important we collect this data thanks to Thomas Levine's amazing painting he made.
And I started working on our package.
He's working on our package about the pizza or about your paintings?
To publish the data.
Oh, that's great. Fantastic. And everyone knows there is a live JSON feed of the data, which I assume Thomas is pulling from. Hopefully not hand encoding. So, everyone's going to go to bit.ly/pizza poll. Next up, any jobs? Is anyone hiring? All right, I see a lot of hands. Are going to do it in order. Well, first, a word from our hosts. Thank you to Google for hosting us this week. Month.
Yeah, hi everybody. My name is Norman. My sincere apology for those of you who had to go through all the badging process, but that's just our security policy. Yeah, as you can tell, this is probably, or as you can probably tell, this is the first time I'm hosting one of these meetups, so welcome everybody. I guess the bare minimum I should do for the company is say google.com/jobs. We are all very passionate about data analysis. We have a large group of internal R users, for example, but you can also work with TensorFlow, Python, Go, whatever your heart desires, and we're pretty much always hiring. This is the second largest campus on the world, so yeah, check it out, and I hope you enjoy yourselves.
Thank you. Thank you. A big round of applause for hosting us today. Next up, I saw a JD hand. He's hiring.
I'll do mine on my presentation.
Your presentation. Well, I saw other hands. Yes. There's a microphone right there if you want to run up to it. I'm not sure the side mics are working yet, but we'll test it out. You'll tell us.
Hello. Nope, not working yet.
Can we have the audience mic turned on briefly? Thank you so much.
Hello. I work for Uncommon Schools. I'm on the data analytics team, which is separate from our data management team, but our data management team is the ones that are currently hiring. So if you're interested in school databases or moving school databases to Amazon Redshift, come talk to me.
Nice. If you can, people who are hiring after the meetup, if you could gather by the stairs over there, by the music symbols, then we'll have people come up to you for a job. Oftentimes, I know job seekers are looking for the job poster, so if you could, you and anyone else hiring, I did over there if you have time. So all the job seekers that then go to the music symbols. I saw other hands go up who were hiring. Right, I'm going to go because that would be easiest to run there. I have another mic. I'll pass around those other.
I'm Ken McCrane, Director of Data Science at a company called Amplify. We're a K-8 digital education company, and we currently have 2 data scientist positions and a summer internship for 2.
And please do your best to stand over there at the end of the meetup. You have a job?
Yeah.
Give the mic right there.
I'm going to continue the education jobs thing. I work for the New York City Department of Education in the Office of School Performance, and we're hiring a research analyst, which is similar to my role. We work on like metrics and that kind of stuff.
And again, music palette when you're done.
Hey guys, I'm Patrick at Via Transportation. If you're interested in the ride-sharing sector or data analysis, we're hiring data scientists and business analysts. Thanks.
Will they get a work of SAR?
Yes.
All right. And also, please, if you're available at the end, check out the music palette.
Hey guys, Phil Gold with HeyStream. We're hiring engagement managers and data scientists. We've built lots of patented products for clients, mostly in financial services.
And you'll check around by the music too. Anyone else? Over here. I think that mic should be hot. I can't promise not. If not, I'm sure we can get it turned on.
Hello. I am Carlin Brickner from the Visiting Nurse Service of New York. I have an open position for a statistician, hands-on in database, relational databases, things like that.
And please, I'm going to keep saying it again and again because repetition's important. Hang up by the music when you're done, when the meetup's done.
Hi, I'm Orit from Fortet Health. We're looking for somebody who's a data scientist / biostatistician.
Hi, I'm John from HBO. We're hiring for data engineering, data analytics, and data science.
Working there is just like Silicon Valley, right?
Hello, my name is Fabrizio. I work at Uber. We have an office here in New York City. We are looking for data scientists.
Can I have the Uber and Via guys fight?
We actually know each other.
That's not what we want to see. Anyone else? All right, that was jobs. Afterwards, we always go to a bar, and we're in a new neighborhood. This is not a neighborhood we've come to recently for a meetup. So we have decided that we are going to go to the Standard Beer Garden. Who knows where that is? Raise your hands. Who knows where that is and is going to come? Because you're going to be the Pied Pipers. And no one?
I presume it's on Google.
You will be one of the Pied Pipers leading people to the bar. I will lead people. JD will lead people.
It's on Google Maps, right?
It's available, not on Apple Maps, though.
Okay.
So afterwards, we'll go to the Standard Beer Garden. It's underneath the High Line, attached to the Standard Hotel. It's the most beery place in the neighborhood. Everything else is cocktail bars, which you know we like cocktails, but we need some good beer and cocktails. So Standard Beer Garden afterwards, we'll send people in waves to go over there. The only hiccup is you have to buy tickets at the door to buy beer, which yes is kind of lame, but that's what beer gardens work. Yeah, you buy a ticket at the door, then you give the ticket to the bartender. Yeah, that's what it is. We have a few giveaways, but I didn't draw any random names. So we need to find a way to give this away. Any brain power here wants to figure out an algorithm to randomly choose people?
Yeah, we can count the seats and we can draw random numbers.
We will draw a random number, then somebody's know where the seats are. No. We can't. Well, we can do it by row and by seat, and then we can figure it out. Section row seat. Okay, that's what we'll do. So we have 3 things to give away. The small prizes first. Would you mind throwing me those 2 T-shirts? Can you have the nice man away?
I thought I was going to live code our sample.
Oh, do you have the attendee information?
No, I was just going to do like row thing.
You live code, I'll give out shirts.
Nah,
all right.
I would be facetious. I'm not going to live code. God damn.
They're both the same. The IR New York shirt, we have a bunch of these. We want to give these away. We do normally sell them, but we didn't bring enough to sell, so we're just going to give away 2 of them. The first thing, we'll say section 2. I'm not sure what section 2 is, though.
1, 2, 3.
All right.
1, 2, 3. So section 2 is here.
Section 2, row 3.
1, 2, 3.
No, we need a real random number.
I'm just going to throw the shirt into the crowd.
There you go. You two, fight over it.
There you go.
There you go.
That's how we do this anyway. So we do have a painting to give away, and I'm not throwing that in the crowd.
Oh, okay.
So we will find a nice way. Whoever screams allows and cheers allows will get us this painting. So.
Oh, that should be your presenter gift. This is beautiful.
That should be for the presenter.
Okay. How about that? Yeah.
All right.
I think we can.
We did
it's
it
a
last
good
time.
idea. The presenter suggested it. I think we can do it for the presenter.
I think that's fair. Because wait, what data set is this?
I can't.
This is a sunflower plot of the iris data set. Unfortunately, not an iris plot, a sunflower plot. And it's just the versicolor sepals, the length on the y-axis and the width on the x-axis, and a sunflower plot, in case you haven't used it before. It's a scatter plot, but it, if there are multiple points on the same point, then it makes a flower instead of just a point.
That's very cool.
Let me get a picture giving it to him. Did I do this wrong? No, but the other time we did it, like,
You're doing great.
Hey, where you look fine?
This looks good.
Okay.
You're doing great.
This is good.
We're good.
That feedback's not good, though.
The other time it looked like I was being given it.
Yes. So here's what we'll do. Actually, I feel guilty because I just talked my way into getting something free. And I'm Southern, and we just can't do that. So I'll be doing an auction, and we're going to, I think, Women Who Code is going to be who receives this. So we'll do it online. I'll figure out exactly how to do that. This may take us a few weeks to get lined up. Jared will help with that. We'll circulate an email, and we're going to raise some money for a charity because this is beautiful, and I feel guilty.
Thank you both of you then.
Can I get a not broken one? No, I'm just kidding.
For those who don't know, Tom made a bunch of these paintings of famous data sets that we auctioned off at the conference, and the money raised went to the Free Software Foundation and to the R Foundation. So it's really freaking awesome. Thank you very much, Tom, for doing this. Last two announcements, then we'll get the show on the road. Next month's meetup is already scheduled. Well, it's not scheduled, though. The page will go up tomorrow. It is Rob Hindeman. Who knows who Rob Hindeman is? All right, let me ask you. Maybe you might have used this package. It's the forecast package. Who's used the forecast package? It's about doing time series analysis. He's coming from Australia to New York City next month. Also, if the meetup's not enough for you, he's also putting on a 2-day workshop. So if you want to actually learn for 2 full days from Rob Hindeman, sign up for the workshop. You'll see the details and the meetup goes up. I'm very excited. I've been asking him for 2 years to come to New York City. We finally got him here. I'm very excited to have him. And then, last question. I've been asking around a lot of people. Do people did you get the title of the talk? Admit if you didn't get it. I know a few of you. Okay.
Everybody under 40 is like, what the fuck? And everybody over 40 is like, oh yeah.
Because I had someone tell me that they were actually they were a little intimidated because they didn't understand the words in the talk and the title. Even though this is a talk meant for beginners. So I want that everyone understands that this is an awesome pun and that we have an awesome speaker who's been coming to the meetup for, well, he's only been coming for a few years, but he's been known to the meetup because of his great twittering at C Mastication for about a decade. So I want everyone to give a very warm welcome to J.D. Long.
Thank you very much. All right, thank you guys. Fantastic. I have tremendous lights in my eyes and not a very good anti-reflective coating on my glasses, so can't see you guys at all. Let's see. I'll cover where the title of the talk came from. This is going to be a beginner's talk. I was talking to somebody earlier who's like, I kind of heard of dplyr and I feel like I should be using it, but I don't really know what it is. Like, you're our target audience. If you're here and you've got years of experience, who's got, more than a year experience using dplyr? Right? Okay, so everybody who came here to hear me, like, these are the people you're going to be asking questions to if I can't answer them. So the reason that I chose this topic is I just learned it myself. I started the Chicago R user group 8-9 years ago. I'm not sure how long ago it was. I've not been a big user of dplyr. There's some drawbacks to some of the Tidyverse packages, and I'm going to cover that a bit at the end. And we're going to talk about some tension that we may have picked up on at the R conference between the Tidyverse and the let's call it the Tidyverse and the Chicago school, right? So there's this, and I'm an economist, so I'm used to the Chicago school having a bit of a beef with everybody else, so this is really comfortable territory for me. So we'll talk about that in a minute. So, some of you are like not going to care about the inside baseball, but it's actually a little bit interesting about why there are different groups of our users doing some different things. And it's worth thinking about because there's some really legitimate points on both sides. And my only technical skill is empathy, so hopefully I can empathize with where each group is coming from and can maybe help you guys understand that a bit. So we got lots of people here from all over. Where's my West Point crew at? I lost them. So there they are. Yeah, these guys got my back if I screw up. So I really hope that my presentation is good because I do not want to end up in the Floorbird at their Humvee with a brown bag over my head again. So. All right, where are we going? I actually spoke more before this slide than I usually do. I'm a big fan of lead with where it is we're going. My wife was a newspaper reporter in her first life, and she said business people always bury the lead. Like, we never tell anybody where we're going, and we walk them through how we got there. At the end, they have no idea that this was where we were ultimately going. So I'm going to start with where we're going. All right, dplyr can be fast to write. It can write SQL for you. dplyr writing SQL is fast, typically faster than you can write SQL, or at least faster than I am. I'm going to have one controversial idea, one warning, and one hack. All right, so we'll stack those up at the end. But this is going to kind of be step-by-step dplyr chunks, how to do something. All of the code is available for this presentation. It's on my GitHub account. So you can download this is just an HTML page. It's got all the pictures embedded in the HTML, so you don't have to get the HTML plus a bunch of other crap. The HTML page has it all. There's also the source code that generated this. You can run it on your machine. It's all in R Markdown. So JD who? I'm JD Long. Also, first name is James. Middle name is David, thus the JD. And I've been on Twitter for a while. About 6 years ago, I moved from Chicago to Bermuda. And the first few weeks I was in Bermuda, Bermuda is a population of 50,000 people, right? Whole country. It's a little bitty island, 20 square miles out in the middle of the Atlantic Ocean. I used to tell everybody, they'd ask, where do you live? And I'm like, oh, I'm about 600 miles east of Ahoskie, North Carolina. And they go, oh. And they'd later figure out I just said 600 miles east of Ahoskie, North Carolina. So I lived out in the middle of the ocean, and the local newspaper ran an article about the Bermudians with the most Twitter followers. I had not changed my location to Bermuda. I had it changed like Somers Islands or something, which is the old name, the old British name for Bermuda. I had it something kind of obfuscated. I would have been like number 6 in the country. I just stopped using Twitter, right? I'm like, I'm kind of new to this position at this company, and I don't want to be the guy who's like Twitter famous over some piece of obscure technology that no one in the country's ever heard of. Yeah, so when I moved back to the States, we just kind of opened the spigot on Twitter again. And so I've been fairly active in the last couple of years since I've been back here. I'm also been in the past really active on Stack Overflow. I was involved in the group that helped bootstrap getting the R tag on Stack Overflow initially, and we did that by seeding Stack Overflow with a bunch of popular questions and answers, like beginner things, in order to drive initial traffic to Stack Overflow. No formal affiliation with Stack Overflow. I was just really pissed off at how grumpy our help was and wanted to like redirect people over to this friendlier environment. Little did I know that apparently Stack Overflow was going to become sort of less friendly over time. But at the time, it was a really good place, and it's still incredibly useful. And even this week, when preparing for this presentation, I asked a stupid question on Stack Overflow, and got embarrassed. So OPP, summer of 1991, 27 years ago, the group Naughty by Nature had the smash hit OPP. And we were looking for a term to capture packages in R that sort of follow the Tidyverse standard, the tidy way of doing things, maybe use some tidy packages in those packages, but they didn't get, maybe I should define what the Tidyverse is, right? So if you type library Tidyverse into your R session, you're gonna get, I don't know the number off the top of my head, but it's this many packages get loaded. And then if you say install packages Tidyverse, you get this many. If you say library Tidyverse to load that, you get this many, right? So it installs a bunch, but when you call it, it gives you this many. So, well, in the vernacular, these packages are like core Tidyverse, and these are in the Tidyverse because they get installed when you type install packages Tidyverse. All right, well, there's these other packages, right? This other stuff. What do we call them? And I've been helping Paul Teeter work on the R cookbook to kind of bring it up. It was written 8 years ago. I was a technical reviewer on it for O'Reilly. And so we're having to explain some of these concepts. So I'm trying to be really precise with my language. And I have suggested that we call these like core Tidyverse. Then there's like recommended maybe or non-core. And then there's these others. And these others, I am convinced, should be called Tidy by Nature. And it's a play on Naughty by Nature, right? Because I'm a white dude who was around 27 years ago. So I'm a big fan of R puns. R puns rock. Has anybody ever seen this syntax in R, sync something to dev null? It just throws it away, right? It takes the output and sends it to dev null. I thought this was so funny that I named my boat dev null. So this is the unsinkable dev null. So. And I'm sure the guy who bought this from me when I left Bermuda was like, what in the hell is this name about? So, all right, now I usually don't talk about where I work. I usually say James Long, magnanimous cocktail party host, or something like that in my bios. I actually work for Renaissance Re. We're a global reinsurance company based in Bermuda with offices big offices in New York, Bermuda, London, small office in Singapore, big office in Dublin. And we have a meteorological group on the East Coast. We are actually hiring. And so I'm usually don't associate because our stock trades down every time I'm associated with the company. But we are hiring a risk analyst here in the New York area, early to mid-career. It's not an R-centric job, but you do get to work with me. It's not reporting to me. It's reporting to one of my peers. She actually sits right behind me. So, but you do get to team with me. And so bit.ly.com /RNR_job takes you to my GitHub page where there's a link to the PDF job description. We do work through recruiters, so you can't like Google and find this. But if you are interested, come talk to me. Pull the job description up there. All right, let's talk about dplyr. So with the lights, I can't really read the back there, so I'm going to have to spend part of my time in profile or with my back to the guys from West Point. We're going to set up an example. First, I'm just going to load Tidyverse. We're not going to load just dplyr and grab other stuff. We're just going to load packages willy-nilly. So I'm going to load the Tidyverse, and then we're going to take this mtcars data set that comes with R, and I'm going to use a function called row name to columns, because we have this data has row names, and row names are stupid. I want them actually in a column. So I create a column named long name, and now we got this thing called df_cars. It's just the cars data in a data frame. Is anybody in here, and please don't hesitate to like give me the high sign, because I need to know a little bit where to start with some of this. Is anybody not familiar with that percent greater than percent symbol? Okay, I've got a couple, three. Look, that's a pipe. And what a pipe does, if you had any experience from command line, especially in Unix, we'll take one command and then we'll pipe the output of that command into another command. And what this does in R is it takes the first thing, or the result of the first thing. In this case, mtcars is just data. It takes that and it pushes it as the first argument of the next thing in line. So here, the row names to column. There's an implied mtcars goes here, comma, var name, long name. So I could have written that out long-wise by putting mtcars as the first argument there. And what about this right assignment arrow? Who in here uses right assignments? Who in here is made slightly uncomfortable by my use of the right assignment? Yeah, all right, I know my audience. Oh yeah, this is my controversial idea. Because this'll divide a crowd, man. The idea is, in R, you can make that little assignment arrow point either direction. As a matter of fact, you can take an object, put an arrow on either side, and it'll assign that middle object to both of those, to the one on either side. Man, R does not give a shit. It's the honey badger of assignment operators, right? It's like, I don't care, left, right to left, man, Jewish, Arab, we don't care, man, let's just do this. So I am assigning, and I love this syntax, because we go from the left, through the next item, through the right, and dump it into an object. This is just like how we would do in the Unix command line, where we do cat something, push it into a function, push it into something else, and then shoot it into a file. It's conceptually the same thing. So I'm going to use that over and over, and we'll revisit it later. So the dplyr select statement is like select in SQL. We're going to say, take the dfcar data, shove it into a select, and just keep these three columns. Now, these three columns are this long name that I created a while ago, cylinder and HP, number of cylinders, horsepower, this is cars data. And then I pipe that into head. Now, I also do something here with head. I don't have any parentheses with head. Head's a function, gives us the top 6 rows, but I don't even have any parentheses there. If you're only passing the thing from the pipe into your function, you can put the parentheses there. You can not put the parentheses there. R does not give a shit, and I don't either. All right, so let's do a filter. All right, so the first line there, long name, cylinder, horsepower. Now, the other thing to notice here, and this makes my friends who come from the Python world uncomfortable. Yes, sir?
If I have a variable named head, what will happen?
Oh, man, you're going to have all kinds of mess. I don't know, and neither do you, so don't do that. Something magical, I'm sure. DF cars here, we're going to select long name, cylinder, horsepower. And you know, for most other programming languages, when you start talking about fields in another object, you got to do like that other object dot the field, or that other object, you know, $, the field name. Well, it's implied when you're using dplyr, and this is part of what makes it fast to type. And so a huge part of analysis is shortening the distance between your head and the end of your fingers. And so if we have to type fewer, you know, DF cars over and over and over in front of every field name, you can dump your ideas faster into code. So the idea is no quotes around it, no qualifying the names, just shove them in there. And all of these functions are going to kind of work like that. So here I've added filter, and a filter does what it says on the tin. It's going to filter by certain criteria. So this is number of cylinders, double equals, so the comparison operator, number of cylinders equal to 8, and then spit that to head. And so now you see it pulled, you know, records where the number of cylinders is equal to 8. So each of these things I'm introducing you to is a verb. You can think of dplyr as a grammar of data analysis, kind of like ggplot is a grammar of graphics. This is sort of, dplyr is a grammar of data analysis. Here we've introduced a new verb. So we got a verb select, we have a verb filter, and we've introduced a verb mutate. What mutate's going to do is create a new column. So I'm going to do a couple of them here. I'm going to do the first one. I don't know, this isn't meaningful, right? I'm just making dummy data to illustrate this, and I wanted short names and short functions. So I did the square root of horsepower and called that square root underscore horsepower. And another one called short name that uses a function called word to grab the first word of the long name. So usually that's the make, right? So it's make and model. And so that grabs just the make. So you can see if you look at the column short name here, you know, it's caught the first word of this. All right, let's introduce another verb, group by. Group by short name. So you may be used to group bys in SQL. And in SQL, whenever you do a group by, it actually like results in data that's been reduced down to the unique number of groups. One thing that maybe it got you when you come to dplyr, or for that matter, pandas in Python, is when you do a group by, it doesn't actually change your data. So if you look down below, like that same data we've been pushing around before, you can see the 3 records there that are all Mercedes. There's 3 Mercs there, right? But yet I grouped by short name. So you might, if you come from SQL land, expect that to have done something. It actually doesn't change the data. What it does change is you look up at the top, it tells you this is a tibble, which is just a tidy data frame, and it says it has groups. It says it's grouped on short name. So that's just an indicator for future functions that whatever we summarize on later will be by groups. But right now it's not by group. It's grouped, but it's not reduced in the number of groups. All right, so I'm gonna do some cleanup here because my example is getting too long for me to just add verbs every time. So we're gonna do a couple things, and also my data was getting too wide, it wasn't fit. I'm gonna do a select with a negative. So you see where I negated long name, that means drop it. So it'll take whatever was there, select long name, cylinder, horsepower, add a column named short name, drop long name, so I'm left with short name, cylinder, horsepower. And as you see when I do a head on that data, that's what we have. All right, we're going to take just a little tangent. Why do this pipe? There's a handful of people who hadn't seen the pipe. What's the sales pitch for why they should go home and investigate the pipe? Because I don't know what the hell's going on in this code. But it does exactly the same thing that pipe sequence did I showed you a couple slides ago. And the reason it's hard for me to read is it's completely dependent on us interpreting the white space to figure out which loop we're in, which function we're in, to understand which argument is applying to what bit. And this ain't Python. We shouldn't be caring about white space to understand where we are. So you can see, actually, it ends up looking like Lisp with all these closing parentheses at the end. You know, one of the complaints about Lisp is it looks like somebody trimmed their fingernails on your code, because you got this hanging out little closed parentheses. But this code runs, and it does the same thing, but what I did is I just nested all the commands inside of each other. Most people don't actually write it like this, but God knows I've written a bunch of code that looks like this. So this is actually really common, and this is what most of us do, right? We'll do a select, we shove it in this thing, like, oh, okay, it's only got 3 variables. I'll call it dfchar 3vars. And then, oh, well, I'm going to add a column named short name. Well, we're going to dfchar's 3vars short name. And then I'm going to do something to that, and then at some point, the third choice, I overwrote my original data frame, but the top one I didn't. So we leave this trail of periodic data frames behind us in our analysis, like shit falling off a truck. And you end up with a bunch of copies, and it can cause a real reproducibility problem when you go back to try to rerun parts, because if you change the data frames out of order, you can have real problems with your analysis. So this is so much cleaner to read, and I think that kind of undeniably so. Now, you may not want to use pipes and everything. You may not want to use Tidyverse. That's fine. You don't have to. But this is amazingly clean to me to understand what's happening. Now, I'm a little constrained because all these examples I'm trying to fit in this stupid little code box, right? And I'm also trying to make sure the records don't fall off the screen that way. So I've tried to pick very concise examples. But in real life, you're going to be a little wider, but it's still really easy to track what's going on. My code is way more readable with dplyr. All right, summarize. I promised we would do something, and it would actually take that grouping business into account. So here we're going to group by short name and number of cylinders, and we're going to average the horsepower, take the mean horsepower. All right, so I've introduced this verb summarize. And summarize, I'm going to need to give it a function that can operate on a vector of data, because it's going to get a chunk. It's going to get whatever is in each group. And so you can think of what ours, or dplyr, is doing behind the scenes is just like in SQL group bys. It's going to effectively take your data frame, conceptually break it into a bunch of little data frames, and like here I'm doing some operation on horsepower, so it's going to take the vector that represents the horsepower column, and it's going to shove that for just that group into the mean function, right? Conceptually really straightforward. And that's what it does. I just print out the top 3. Now, but something you may notice, and this was a real gotcha to me, and I didn't know what was going on. I ran into this where it changed what I was seeing or made a function not work like I was expecting. You see I group by 2 things right there, right? I group by short name and cylinder. But if you look at that result of that, it only is grouped by 1 name. It's only grouped by short name. Anybody here know why that is?
Summarize will drop the last bit.
There's the answer. Ding, 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 ding. Summarize will every single time drop your last group by variable. That is in the documentation. It's how it's designed. And from looking at the GitHub history for dplyr, about once a month, somebody says, what the fuck? And I know this because I went there to say what the fuck. And so I actually proposed a change that dplyr present a message that says, hey, we're dropping. And Hadley told me, like, look, no, because this is the expected behavior. Grouping, when you group, we've left with a grouping that is only 1 row, which is what it has to be after you've run 1 group by. Having a grouping that's only 1 row big is not useful. It is never useful, and so it doesn't conceptually make sense. So we just drop the last one. Well, okay, that makes sense. I'm with you. And I've actually, the funny thing is I've actually used this as a feature, because you could do a group by, and then you do another summarize, and you've got 1 less grouping automatically. So if you know you're going to do that workflow, you don't have to do that second group by. You just put the variable you want to drop as your last group by element. It falls off after you do the summarize, and you're right where you want to be. So in some ways, you can end up writing less code. Just it can surprise you like it did me. Well, we can do joins, just like SQL, and we do joins in base R. In this case, I'm creating some dummy, like a dummy mapping table off to the side where I map the numbers 468 into the words 468. And then I join them to the dfcars limited. And you'll notice I don't tell it what field to join by, right? Well, dplyr will look and say, okay, you've got a field called CYL. This data frame that you're joining to has a field called CYL, and it will send a message saying joining by CYL. It will just find all of the, if you have multiple common names, it'll join by all of them. If that's not what you want, you can override that and tell it what to join by or to join on. But that's pretty neat. Once again, it can be very concise when you're typing this out. All right, we can do case when. This is another verb in our dplyr verb. We're almost through with verbs. I'm going to illustrate a few more of these and then just show you the list of the rest of them and send you home to read up by yourself. But this one I have found incredibly useful. So I create a variable here. I mutate, so I'm adding a new calculated field called POW. And POW is when the horsepower is over 200 and the cylinders are over 8. We call it strong. And then I just do this thing where I say true weak. Well, what I'm doing here is the way case when works is you give it conditions. So that's one condition, horsepower over 200 and cylinder greater than or equal to 8. Both of those have to be true. And then see the twiddle? So this is like formula notation. So we say when the stuff on the left side of the twiddle is true, we do the thing on the right side. Well, the thing on the left side of the twiddle in my second line by week is just true. It always evaluates to true. So this is case when, right? This is if then else. It's your else, right? So as soon as it hits one that's true, it will do that. And then if it doesn't meet any other criteria, it'll do the other at the very last line there. All right. I've been using mutate versus summarize. Pretty straightforward after you've used them, but let me just reiterate. Mutate adds columns, but keeps the same number of rows. Summarize adds the column, but reduces the rows down to one per unique group based on whatever you were grouped by. So should be pretty straightforward, but they're kind of similar concepts. They both can be used to add columns. All right, that's great. And that's all been on local data frames. Let's do database. So this is what brought me to dplyr and why I decided to learn it about 6 months ago. Let's make a connection. In this case, I'm going to just do a connection to a local SQL database, an SQLite database just running on my local machine. And I could use this convenience command called memdbframe, and it would do the same thing. But I want to show actually making a connection, because if you were connecting to Redshift, Postgres, whatever your favorite database is, you would do it like this. You would create some sort of DBI connection string, probably call it con, and then you would use that connection. So what I'm going to do is I'm going to actually copy some data. So my copy to is a dplyr command that's going to copy data to the connection. It's going to copy the dfcars data frame. That's this one we've been playing with. It's going to put it in a table called dfcars, and I'm going to set temporary equal to false, so it'll still be there for multiple commands. And I'm going to do this connection. So that's connecting to the database. Now I'm going to make a connection to the table. I'm going to make this dfcars underscore db is going to be a tibble that I can act on just like the other tibbles, which are tidy data frames. I can act on it the same way, but underneath, it's actually my database. So I do the tbl command, tell it the connection, tell it the name of the table, and now I'm connected. So if I look at what class each of these things are we've been throwing around. So dfcars is really straightforward. It's a data frame. If I wrap it in as tibble, so it's a local data frame, dfcars, I wrap it in as tibble and say what's the class. It's this tibble.df tbl data frame. We call it a tibble. It's still just a tibble. And the third one, if I take the dfcars db, it's a tibble. Now, it's a tibble that's got this SQL and DBI thing in it. And that's how I know it is a tibble like backed by remote data. Yes, ma'am?
Can you go back one?
Yes.
I want to make sure. So did you create connection to a database some sense importing it back into R as TBL, as Tibble, but it's actually like if you connect to the database and the database shuts down, you will lose that dplyr DB. It really is a live.
Correct. And I'll reiterate that just to make sure. She asked, did I connect to another database, an outside database? I said yes. In this example, it's local to the machine, but this could be my Redshift database on Amazon. My copy to command here is let's set up dummy data. Like in my real life, I already have crap over on database, right? And then the third step with this dfcars db, I think of this like a logical link in your file system. It's a pointer to something over on the database, but I didn't move any data back yet. It's just like a placekeeper saying, this data is gonna come from there. It's like a promise that I'm gonna use that data behind this thing, but not yet. And we're gonna execute on that. The takeaway here is really, if you see this TBL_SQL when you do the class, if you get confused or you're debugging, that tells you it's backed by this like remote promise, or I'm not sure what the right way to describe this that will resonate. All right, so this looks sane, right? This is going to look a lot like what we did a while ago. I think I changed a little bit, but we're going to take this dfcars db, which is now living over on our database, and I'm going to pipe it through a group by, then I'm going to pipe it through a summarize, and take the average and standard deviation and call that thing mean horsepower by cylinder, and then take the head of mean horsepower by cylinder, and it just runs. But this didn't run on my machine. Well, it did because this database, it didn't run in R. It ran because of an SQL query behind it, created on the fly by R, by dplyr. All right, so this is that same query, but the last step, instead of shoving it into this object called mean horsepower by cylinder, I just shove it into a function called show query. And it dumps out the SQL that would need to be run in order to get that result. So this thing is dynamically writing SQL behind the scenes, right? All right. It's kind of smart about how it does it. So if I had this workflow where I do a group by, then I do a summarize, and then I do a filter. Well, my filter is after the summarize, and then I show the query. You can see it's smart enough to effectively, I changed the form just to let you guys know if you do this at home. It's not going to, output's not going to look exactly like that. It's going to kind of dump it in a run-on sentence, and I've formatted the SQL so you guys could tell what the heck's going on. But this is the SQL you get out the other side. I just added formatting. But you can see it does the selection and the group by, and then it wraps that in another, select star, and then do the where condition down at the bottom. So it's kind of smart about the SQL it writes. And I heard mention a while ago someone's using Redshift. We use Redshift, and what I found is these queries that are nested like this are super, well, they play very well with a query optimizer in Redshift. And so the SQL that I might try to use some temporary tables, or try to do CTEs or something in my SQL. I found this sort of nested SQL. The query optimizer can traverse it and understand what's going on. The query optimizer over on Redshift. And my queries become more performant than that which I might write by hand, only because these are fine when you just got a couple of nests. If you have once you get 7 deep and you got a bunch of fields, these can get god awful to keep track of. So, oh yes, it's magic. Now, I mentioned lazy. I think I used the term lazy, and you may have even seen the lazy mentioned. The Tibble was a lazy query. What does this mean? The lazy means dplyr doesn't go get the data until it needs the data. And you either explicitly ask it, we're going to use a command called collect, to tell it, go get what's in this Tibble that's backed by SQL, and then it'll actually materialize it on your local machine. Or if you call a function, like earlier I called the head function and it needed some of the data in order to present a head, it'll do that in order. But If you do the head, it will just get what it needs. It won't get your whole thing. So this can be really useful. So here I pull in and I put local in front of it. This is kind of a, when I'm debugging stuff or using this, I have gotten where I take to putting local in front of stuff I have returned from the database so I can keep track of what's a pointer to something over on my database and what has actually been materialized back to my session of R. So by using this collect command, it tells dplyr, go fetch the data, shove it in that data frame. So there's a whole bunch of R that's been mapped to SQL, but it's pretty short list compared to all the things you can do in R, right? So this is basic data manipulation verbs. What it doesn't have is all of our statistic functions, our building regressions and all that. That's not easily conducible to SQL. I've seen the SQL that does a correlation matrix in SQL, and it made me want to punch the guy that wrote it because it's just the wrong tool for the job, right? So what we need to think about doing is this is a tool that allows us to take a chunk of our data out, bring it a manageable chunk, either because it's an aggregate, it's a grouped in some way, it's a sample, because you can do samples with this and sample from your database, take a random sample, or a subset, bring them into R and do something interesting in memory on a local machine. So this is one of the design patterns for big data in the 20th century is a whole bunch of time you don't need all your data. You just need some aggregation of it locally to do something meaningful. And this bridges that gap, especially if your big SQL thing on the back end is like Spark or Amazon Redshift. Sorry, need more? There's a vignette for the SQL translation for dplyr. I haven't used the term dbplyr in here. Behind the scenes, there's a package called dbplyr, and it's all the backends for dplyr. The backends to connect to the databases. So you may see that mentioned. Oh, I've got to get a picture of that. All right, I want to talk about a few kind of advanced, not advanced, a few out of mainstream situations. One is you need to produce a reproducible example in order to ask somebody on Stack Overflow or somewhere else for help. Well, you can't give them access to your database, right? Usually you can't. So how do you ask for help, right? Because the first thing, if you don't, they're going to say, well, that's a really interesting problem. I wish I could help you, but you don't have a reproducible example, so go fuck yourself. And they kind of got a point. They kind of can't help you. Well, Headley sort of saw this coming, and then the other people who did dbplyr. So I'm actually going to load dbplyr here. And we're going to use, you see me making a data frame here. I've got this X and Y. All I'm doing here is telling it, I could have put 1 for both of them. I'm telling it that X and Y are both integers, right? I just need some placeholder data. We're never going to use the actual data here. We're using this to create dummy SQL. And this is useful also for debugging yourself. And I'm going to use this 2 commands together, tbl_lazy and the source equals simulate SQLite. So what that does, I pipe my data into that combination of functions, and it creates this lazy table called df_SQLite. What that is enough of a trick to tell dplyr this is an SQLite database. It's not an SQLite database. It's just a placeholder. And if you dump commands against it, like I do here with summarize, and then you do show query, it will show you the SQL that it would write if you were using an SQLite database. And you take this exact same command sequence, change the backend to like simulate Postgres, and it will show you the SQL that it would write if you had a Postgres on the back end. This is how you create dummy examples for understanding for yourself what it will do, but more importantly, so someone else, if you're reporting a bug or if you're asking someone else for help, you can actually illustrate what it is you're seeing. You can say, I do this and I see this. I expected to see something different. Why am I seeing what I'm seeing, right? So it allows you to make a reproducible example. Incredibly helpful. We can simulate a bunch of stuff, Postgres, ODBC connections, SQLite, MySQL, Impala, Oracle. These are also all the stuff that we have backends for in dplyr. All right, a couple of snags, at least for me, that I've run into. One is like when I connect to Redshift, I have different things in my search path automatically. So like we have a database schema called public, one called reports, one called sandbox, and one for me as a user. I've got to explicitly state that. You'll just get the one default. I have no idea what other databases do. All of my in-anger usage has been against Redshift. I bet it's the same way with Postgres, because Redshift has Postgres as the interface. It's like Postgres with a different data store on the back end. So I'm suspicious other Postgres act the same way. Just know that that's a thing. Like if you can't find your table, it may be because it's not in your default search path. Name clashes on join. So if I join, what we do is we have, for convenience, a certain field may be in multiple tables. If I join all those up and it's not a field I'm joining on, it just was put in a couple of different places because of how we use the data. It's duplicate data. We didn't fully normalize our data on purpose. If it gets that field, Bob, and Bob is available in 2 tables, and they all get joined to 2 dim tables, and they all get joined to a common fact, you can't have like a resulting thing with 2 tables called Bob. So what it's going to do automatically and invisibly is the first one's going to become bob.x, and the second one's going to become bob.y. That can be a real surprise, like because you won't have any Bob table. You've been used to having Bob, and Bob's gone, man. What you can do is, if you notice on my connection where I do the TBL, connect, DF cars, I also threw in a select minus. Sorry about the poorly placed line break there. It was not like that before, I swear. I drop, in this example, I might have 2 weights. So I just drop one of them from one of the tables, right? And that prevents me from having a naming clash. And then I get, in this case, a WT field, or in my other example, I get one Bob field, not bob.x, bob.y. All right, my workflow with Redshift, right when I was doing this afternoon, I did a count, and so we have 350 roughly billion rows in our Redshift database that I'm pounding on every day, right? Most of my queries complete in about a minute, right? So it's pretty reasonable database. What I do is I predefine all my joins, so all that TBL business, and then I do all my joins. So maybe I join like 10 dim tables to 1 fact table. I do all that in a function or in something that I source. So that's kind of done behind the scenes. My scripts don't have that junk in there. I just start with like one big table that's everything in my whole freaking database kind of logically joined up into one table. And then I set up a bunch of where conditions, a bunch of group bys, do some transforms. Some of those are in functions because I do them over and over again. And I do all my transforms, and then all at the end of it, I collect it, right? And I may be only getting back 100 rows or 10 rows, something significantly smaller. This is a pretty good workflow for what I do. I don't know if it'll work for what you do, but it's a way to think about workflows. All right, let's talk about what happened at the R user conference here in New York when Jeff Ryan spoke about dplyr, and he said, you should never, 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 never break an API, all right? And I think a bunch of people didn't realize like what Jeff's talking about. What Jeff's talking about is dplyr stomps all over existing API. And it fundamentally changes R when you load it. And I'm going to time series data. I do a lag on it. 12 unit lag, so an annual lag, and I get some data, right? And I can set k equal to 12 or just pass it a 12, because k is the number of units to lag, and it produces the same data either way. This is how R worked and has worked. That's how S works, right? This lag function goes back pre-R. All right. Now if I load dplyr and run that exact same command, changing none of my code, I get an error. And it doesn't matter if I say k equals 12 or k not equal 12. This error is caused because LDEFs is a time series object, and the dplyr lag function doesn't work on time series objects. Well, you get at least a meaningful error. It's like, you sure you didn't mean stats log? All right, so go in here and put stats lag, not log, lag in here. And all right, we're back to getting what we want. We fully qualified it as stats. Well, you have to change all your code. If you've got an existing code base and you want to bring dplyr into it and you're using lag, you got to test and change code. All right, here's the problem though. If you had, instead of LDEFs being time series, I converted it to a double. That's the only thing I changed. So now it's a vector of doubles. And then I run it through. OK, that works with the old lag. It gives us the same thing. But with dplyr, we get nothing but nans. If you aren't printing that vector out or have something that doesn't like nans down the road, you could just be getting wrong answers. And if you're in a high-frequency trading shop, you could lose a crap load of money before you figure out that you broke your code. And that's problematic, right? So this points to, if you're using your code in anger beyond desktop analysis to actually make money, when you start adding new packages, whether it's dplyrs or other, make sure you got regression tests. Make sure you got something where you can say, does this thing change the answer in some way? So, I was fortunate enough to be hanging out at the bar with Jeff and David Robinson. And this is pretty much the conversation as I heard it. So, a lot of the argument is that the Tidyverse and dplyr are the best tools for learning R. And I think David Robinson has a great point. I think they're very, very tractable, and it's a great workflow, and I'm using them, right? I'm using them in anger at my office. Jeff's like, yeah, it's the best way to produce hidden errors in your code base. Jeff works in a hedge fund. And their code needs to have a different degree of stability than other people's code. I don't know where your code sits. I know where my code sits. And I'm going to take this to heart, right? There's good points here on both sides. And so this is the gist of why there is some Tidyverse pushback. From parts of the R communities. Parts of the R communities look like, whoa, man, you are upsetting the apple cart entirely too much too fast, and your stuff will just break our code that's worked since S. Like before the R language existed, what we used worked, and now you're breaking it. And that doesn't feel right. And then there's other groups that say, all right, we're really writing, we've got this long future of future users, and if we change some things now for the future users, there's more future users of R than there are current users, right? So how do you discount a time flow of future users? Well, these two people discount it differently, right? And that's OK. But you got to know how you discount it when you're figuring out what works in your flow. So, all right, the other controversy I mentioned was this write assignment. I use this. I just want you to know that Hadley Wickham is recorded on the record as saying, this is really appealing, really easy to read, and don't ever do it. I'm doing it because it's beautiful in my opinion. It doesn't break anything, always works. The one thing, notice there's no left indent on my result. I really think you need to always do that, because if you have it up after the arrow on the right, it gets hidden. It may even get cut off if your text editor isn't wide enough, and you can't figure out where some assignment happened, you lose it. Make that thing always left justified. Now the problem is if you take this code block, copy and paste it, RStudio will conveniently bump that fun data here. It'll bump that over, because it's like, oh no, that doesn't go all the way over there. So if I can get enough people using it, we'll ask RStudio to change that algorithm. All right. Last thing before I wrap up is some people, myself included, have functions that aren't vectorized. I glossed over the mutate, just, oh, mutate adds a column. If your function that you want to add your column with is not vectorized, you can't just like mutate add it, right? Because R doesn't know what to do. You'll actually result with everything in that column being exactly the same value. I'm not going to explain this. This is all on GitHub, and we'll circulate a link. This is how you do row-wise iteration using, well, first I just set up the data and a function. And then I set up a row-rise operation where we use pmap from per and list. to pass named objects. This is really useful. I feel like I've taken entirely too much of your time, so I'm not going to get into the details of it, but go for it. Just know that you can also shove vectors in the cells in data frames. People forget they can do this. This may or may not be a good idea. Usually people discover this by accident because they didn't intend to return a vector, and they're horrified because Excel usually doesn't let you do that, right? And that's our analogy when we come to R. Know that you can do that, and there's times it's the right thing to do. It allows you to keep this tidy workflow where every row is an observation, because if you've got an uncertain number of things you need to shove into a cell, this does it and leaves you with a tidy data frame, so it's got some appeal. Use it carefully, know you're doing it. And on that, I'm just going to ask for some questions. So I've kind of dumped a lot at you guys. Let's see, we're going to get both mics on, and Jared's got a mic. So
if you have a question, line up at these microphones. Someone line up. Don't make JD feel like no one wants to ask a question.
Go for it.
So where do you get the list of the functions that work with the SQL?
The vignette that I pointed to, the SQL translation vignette, the one with the cat. I think it's one you got the picture of, yeah. So I'm sorry that you won't get the actual kneading motion. Unless you took a video. You took a video, yeah. That's where you get more.
Yeah, because they don't all work. Like a cut doesn't work. But
correct. Not every function is mapped there.
So that was awesome, thank you.
You're welcome.
My question is about dplyr and data tables. My point of reference is data tables. I'm not sure if you are familiar or not. I was wondering if you'd offer a point of view on the pros and cons of the comparison.
Yeah, first of all, we should state they're incompatible, right? You're not going to shove data tables through these dplyr functions because data tables have a completely different syntax for operating with them. They aren't like data frames. Data tables are super cool. They're very performant. They're really fast. Usually, I am of the opinion people ask me if they should be using data tables, and I'm like, do you have a performance problem? Right? Because you got to learn a new API, a new syntax to interact with them. And that can be really useful, but you've also got to forego some other tools. So most of my life, I'm constrained by the distance between my head and my fingers, like getting the idea captured in code is the hard part. The runtime is actually, with the exception of some of my long queries, usually not my biggest constraint. I use data tables hardly at all. I used them some years ago to try to understand what they were. The people I know who use them have workflows where you've got big tables doing lots of transforms and maybe even lots of looping. And I haven't benchmarked their code, but I'm suspicious they need it for those reasons, right? So it's a trade-off.
So that's exactly the use case we have. We have 10 years of big data.
Yeah.
We load it all in memory with a data table. Awesome and fast.
Yeah.
Any sense in dplyr comparable in speed?
Oh, dplyr will be slower in terms of execution speed. Now, what's interesting is at some point there's okay, I'm an economist, right? So I'm gonna start using economist words. There's a fixed cost, marginal cost piece to having your data on a remote database. So I just showed you we have 300 something billion rows. When I send off a query, every query takes at least as long as it takes the processor to dump that query over the wire, go to Amazon, get executed, marshal the data back into an object, and slurp it back over. I think of that as but there's some chunk of that's fixed cost, right? It doesn't matter how big the table is, that's got to happen. And then there's a marginal component about how much data am I bringing back. So if what you do a lot of is some operation that doesn't bring a lot of data back or can leave it in an SQL database until you only have to bring a little bit of data over, I'd benchmark that against using something like Redshift with dplyr. I can't just blindly give you guideposts because I don't really know. It totally depends on your workflow, right? Yep.
question about our package check and using names in dplyr without comments on.
Actually, I may ask you to stay there because I'm only vaguely familiar with the problem. The snag becomes when you don't fully qualify the function name. Is that what happens? Or what is the?
Yeah, you had a recommended usage there where you refer to the names of fields in a table as part of your pipe expression.
Yeah.
But when you put that into a package and try to check it, it says, oh, of all these unrecognized names, you also have a package check.
Yeah, I saw. Does somebody know the workaround for this?
I do have a workaround, but I mean.
Yeah, what's your workaround? Because I don't use these in package stuff, and honestly, I don't even have a package on Crayon.
It feels natural, and when I get complaints, I put $dollar for every name.
There you go. That was the. I had seen that, and I couldn't pull it out of my memory bank. Yeah, it's $, and then it knows they're fully qualified. Yeah. So
you can also put them in. There's a special function you can call like in your root of your package, like set names or something. That's not the right function. It's like set. Let's call it set names. You give it all the names you would be using in there. That's another way around it, which isn't pretty either.
Yeah. So if you're going to use these in packages that are going on Crayon, you got to throw a little bit more at it. I was just going to mention, I glossed by it because I didn't delve into it. Jenny Bryan from our studio has I have a bit.ly link there, bit.ly row-wise. She has a document full of examples of row-by-row workflows with dplyr and or per. If that is appealing to you, I recommend like taking a picture of that link.
Yeah, really quick question.
Yeah.
So I was trying to Google this like a really simple answer to it. So is there like an efficiency advantage to using summarize with a Z versus summarize with an S?
There's actually a really, really simple answer for that. One works faster in New Zealand, and the other works faster in the United States. It's completely because, well, do you guys know why Tibbles are called Tibbles? Because that's the way a Kiwi pronounces table, right? So it's the New Zealand accent. Someone says table, it comes out like Tibble if you're from New Zealand. So that's the summer. That's with the, I call it the metric spellings, right? It's the that's what those are. It's completely the same function underneath. Yeah, go for it.
Hi, love the presentation. I can't believe you've only been using dplyr for 6 months.
Yeah. Well, I'm a quick study.
I can tell. I've been using it for over a year, and you know way more than I do about it. So I was actually just kind of, I didn't realize you could shove vectors as cells into a data frame, but it's kind of awkward to do that. I was wondering if there's a kind of a way you prefer to do that, because like, you know, if I'm loading like a CSV data, I'm not going to have a column with vector stuff, so it's like, do I want to create a list every time I want to shove a bunch of data, a bunch of vectors into a column of a data frame, or do I need to create a data frame and then put that into the data frame?
I'll explain the workflow where that happens is you're trying to be tidy. And by tidy, every row is an observation, every column is some variable. And one of your variables has multiple stuff, like multiple observations for some multiple aspects of one variable for that observation. You got two choices. You can either replicate your row, so that row, maybe each row represents a person in a study. You could replicate that row, and each row being one time they were measured for the whatever test it was. That sort of breaks this tidy paradigm where you have one row per participant in your study. So you may choose at that point to, when you bring that data in, munge it around in such a way that you're basically putting comma-separated values effectively inside of individual cells conceptually, right? It's a vector. It shows up when you print it out as comma-separated. Or if the result of, for example, I could shove the result of a linear regression in a cell in a data frame. That might not be a bad workflow in certain cases where you're doing a different linear regression for every piece of data in your data frame. You might want to shove a whole result. It's one of those things that should be done judiciously because you do break something when you do that, right? It makes it a little hard to have a meaningful CSV that you can dump out into other stuff.
Yeah, just imagine like you're running like 100 linear regressions and you want to save the coefficients somewhere.
Yeah.
So it's like I almost almost seem like an intermediary to store those coefficients before shoving it into another data frame.
Yeah, you can shove it straight into the data frame, right? Or you can put them as individual records into a master data frame and then join that to your data frame. Just think about it. This is one of those things you know, it's kind of like how Mark Twain said he went broke, you know, really slowly and then really fast. Well, you'll kind of find that when you'll not use this at all, and then you'll use it like 4 or 5 times because it'll be the right solution for the workflow you have. And I can't imagine what workflows you will have in the future where it's meaningful. Don't make that happen. Like, but if it makes sense.
I remember I had a time where I needed to do this and I couldn't figure out how to do it, and I realized like, oh wow, okay, I could have just done that.
Yeah, the example where I did it, I used the map function. Usually, well, the reason that happens is the sequence function returns a vector. It produces a sequence from A to B by C. And so if you look down here in the bottom, what I did, min, max, range, A, B, C. So we go from 1 to 8 by 1, so that's 8 numbers. We go from 2 to 13 by 2, that's that 2 to 12. And then we go 3 to 18 by 3, and that's that 3 to 18. It's because that function returns a vector, this workflow will just shove it into a cell, right? Pop that whole vector in there. The example before it, what happened, I had that right there. I had the function, that sequence wrapped in a sum. I just added those numbers up because I wanted single atomic values for my illustration. And there, I just left that sum off so I would get a vector. But that would be how you would build that, right? That PMAP can take, it'll put the whole result of that function, fun2 here. It'll pass it those variables and then drop it into the row. So, give it a try. See if it's fun. Anything else? Thank you guys for a chance to come. Appreciate it. Thank you.
Excellent talk. Thank you very much. Just a reminder, we're going to the Standard Beer Garden. We'll get a few people to lead the way, and I will join. Next month's Rob Hindeman speaking about forecasting, and he's also giving a 2-day workshop on forecasting. Be sure to check those out. And then we have more and more stuff coming up throughout the year, so come and join. Thank you very much, everyone. Another round of applause for JD.
Appreciate it.
Come talk to me if you want to learn more about the next meetup or the workshop or the bar.
Thank you so much. I've already lit up.
I needed to hear. I wanted to see how you could write up SQL code, literally output.
Yeah.
That's exactly what I wanted to say.